In July 2025, stargazers detected 3I/Atlas, marking only the third interstellar visitor ever observed hurtling into our solar system at breakneck velocity. Yet once the James Webb Space Telescope picked up a rhythmic, persistent radiance emanating from its heart, a luminescence no ordinary asteroid could produce, the entire scenario shifted dramatically. The entity's luminosity soared to triple the anticipated levels, devoid of any cometary trail or variability. Its spin maintained flawless regularity. Then the real bombshell dropped. Various research squads verified a thermal rhythm throbbing every several hours, alongside a barrage of bizarre radio emissions that defied all recognized natural phenomena. Should this hold true, it might represent the inaugural proof of an artificial construct, not a cosmic accident, barreling our way at this very moment. So what exactly is 3I/Atlas? And why is its approach prompting the planet's leading experts to press for urgent explanations? August 6, 2025. Buried within the influx of data from the James Webb Space Telescope, a team of near-infrared spectroscopy specialists noticed an anomaly that defied logic. Initial IR captures of 3I/Atlas revealed a focused blaze at its center. This wasn't a dispersed fog or a broad envelope, just a compact, pinpoint emitter potent enough to eclipse nearby particulate matter. The data arrived pristine, free from equipment glitches or interference from solar bursts. In the unprocessed graphs, the thermal imprint was glaring, a searing central hotspot tapering into spectral gradients, all anchored to a core beyond the reach of any observatory's resolution. Under the guidance of Chief Instrument Expert Dr. Lena Marovich, the Webb crew reviewed alignment records and recalculated the figures. The output remained constant, registering at 3 times the intensity forecasted by simulations for an entity of its dimensions and remoteness. Absent was any streamer, any wavering, just a resolute, unyielding signal. The group's private discussion channel buzzed with inquiries. Could this be venting gases, or was it something more exotic? Historical data dives commenced right away. Archival info from Hubble and other scopes captured earlier that summer suggested an energized body already aglow well past Jupiter's path, ages before solar rays could ignite standard comet behaviors. However, none of those archives echoed the sharpness or vigor of Webb's fresh visuals. To the technicians, it was evident. This wasn't your everyday find. The warmth originated from profound depths, not the exposed exterior, and the force driving it operated outside conventional norms. Optical monitoring units, spearheaded by the Atlas crew in Chile and Hubble evaluators, launched their independent verifications. Their initial worry centered on luminosity. Across all conventional gauges, 3I/Atlas gleamed at almost thrice the brilliance projected for a form of its approximate scale and separation. Photometric analyses spanning weeks depicted a consistent, rock-steady emission. 0 troughs, no spikes, no traces of the instability typically induced by gas ejections or irregular topography. In contrast, ordinary comets wax and wane as they spin, their frozen shells exhaling sporadically. This one's profile was nearly level, with a documented spin cycle of roughly 6 hours, ample to expose significant crustal dynamics, yet none materialized. Hubble's sharp-focus snapshots hunted for the signature streamer, the elongated vapor jet denoting sublimating frost. Rather, the visitor was encased in a snug, droplet-like sheath, resembling a veil more than an appendage. Experts observed that even at 6 AU from the sun, where illumination is faint and most comets slumber, 3I/Atlas was already energized, shining vividly amid the void. No theory of stellar warmth or routine degassing could account for the potency or the onset. These inconsistencies posed a riddle for the visual squads, an entity overly luminous, excessively stable, and overly compact to align with established types. Standard comet principles simply didn't hold. For the investigators, the path forward was obvious. If the illumination wasn't surface-derived, the solution might lie buried within. Infrared specialists on the Webb side started parsing the sequential datasets, probing for rhythms in the thermal efflux from 3I/Atlas's nucleus. What grabbed them wasn't merely the strength, but its cadence. Approximately every 4 hours, The inner radiance expanded and receded in a measured, purposeful oscillation. The throb was undeniable, uniform, nearly machined, with power surging at the epicenter and propagating in ripples. No erratic twinkling, no disorganized eruptions. The records overflowed with timed entries, each logging an ascent and descent that recurred with eerie accuracy. Dr. Alina Marovich and her colleagues charted the timings against the object's spin and trajectory details, hunting for earthly origins. No correlations emerged. The warmth ignored terrain variations or stellar exposure. It emanated from the interior, immune to shifting solar angles or orbital spacing. To the Webb staff, it resembled less a comet's expulsion and more the pulse of a crafted mechanism. Radio facilities spanning from California to South Africa directed their dishes toward 3I/Atlas, scanning for electromagnetic hints outside the visible and IR spectra. The Allen Telescope Array, under Dr. Kavita Ralph's direction, started combing sifting through extensive wideband recordings. The researchers filtered away ambient noise and satellite interference, zeroing in on an outlier. A subtle narrowband signal pulsed at regular 4-hour intervals, maintaining a consistent cadence. Fourier examination validated the regularity. This steady waveform sliced cleanly through the interference, displaying a periodicity far too exact for mere interstellar static. Across multiple evenings, the emission remained constant, though its schedule shifted in tandem with solar wind variations, aligning precisely with readings from space weather stations. Separate groups at Meerkat and Ethelberg corroborated the detection, eliminating possibilities of nearby disruptions or Earth-based origins. The signal's endurance, its nuanced responses to environmental alterations, and its duplication across hemispheres compelled a pivotal inquiry. Could this stem from a natural phenomenon, or was it an intentional broadcast from an entity attuned to its environment? In mid-August 2025, the mystery intensified. The Webb telescope's real-time stream captured an abrupt burst. 3/2/Atlas surged in brightness by almost 40% within an hour. The monitoring probe in Earth orbit validated the increase. Observatories focused on it all detected the identical peak, extending beyond optical wavelengths to include heightened thermal emissions. For a short period, the body glowed as though an internal system had activated. Moments later, readings leveled off, settling at a higher steady state. Focus turned to its path. Marco Macelli and the ESA's near-Earth object specialists updated their simulations. Projections based on prior observations no longer aligned with the actual route. Rather than floating aimlessly, 3/2/Atlas altered its course, curving nearer to the ecliptic plane. Macelli's colleagues weighed potential explanations, venting gases, observational inaccuracies, or an unfamiliar factor. The speed-up contradicted conventional comet dynamics. For the first time, observations suggested directed control, with the burst and directional shift synchronized in the records. The dilemma grew more urgent. What sort of entity adjusts its path en route? And why in this remote ecliptic fringe? On August 18, 2025, the Webb's near-infrared spectrometer passed data to the spectroscopy experts. Carrie Liss's team at Johns Hopkins spearheaded the effort, scrutinizing the unprocessed spectra from 3/2/Atlas. Standard comet indicators, water, frozen volatiles, CO2, appeared, yet overlying them was an enigma. Multiple spectral dips defied matching against established databases. The surface reflections suggested metallic composites, including traces of rare earths, typically linked to sophisticated Earth-based production. Embedded within were signatures resembling hypothetical quantum substances, concepts outlined in theoretical physics but unseen in the wild. To the analysts, these clues diverged from haphazard spaceborne reactions, evoking instead something artificially constructed. By month's end in August, raw observational streams faced stricter controls. NASA and ESA internal directives invoked fresh guidelines under planetary defense pretexts. The SEI task force, under an undisclosed leader, grappled with sending a mathematical greeting toward 3/2/Atlas. Following a fraught decision, they dispatched it. Sequences of primes, the elements table, and fundamental values. Precisely 72 hours afterward, a focused response emerged. Timestamped to the second. Though warped, The incoming pattern echoed the outbound sequences framework. Officials sealed the findings, diverting exchanges to secure networks. Public conjecture exploded. Internally, the mood evolved from intrigue to guarded restraint. During the August 1st AU Symposium, for primary hypotheses, gas ejections, nuclear warmth, particulate diffusion, and mass calculation flaws, underwent scrutiny and fell short. None accounted for the sequence of irregularities. With the September close approach looming, anticipation builds. All sensors stand ready, awaiting revelations to resolve the enigma. On August 6, 2020, the James Webb Space Telescope detected 3.2/Atlas releasing infrared radiation threefold more intense than size-based forecasts anticipated. In subsequent weeks, specialists noted a focused pulsating thermal pattern, a recurrent radio emission, and a sharp 40% luminosity jump that synced with a path deviation. These details were affirmed by TESS, Hubble, and ESA satellite observations. Spectral breakdowns uncovered exotic metallic blends and unidentified absorption features absent from existing inventories. After numerous external evaluations, the International Astronomical Union panel dismissed organic rationales like venting, isotopic breakdown, and particle haze. As of late September 2025, its nearest past nears, with premier facilities gearing up for intensive examination. Undeniably, 3.2/Atlas upends prevailing theories on extrasolar visitors, and its impending Earth transit marks a turning point for astronomy.